Hi, my name is Jennifer Brandis. This is my week 5 presentation for my supervision class. I want to talk today about the refractive states of the human eye. I currently work as a certified ophthalmic assistant through the Gunderson Health System. I work at all of the regional clinics, all 15 of them. I've been to all of them. So I feel like I'm pretty well versed in the refractive states of the eye. Now, a lot of people are probably wondering, what is a refractive state of the eye? It really just means why you need to wear glasses. You know, the majority of people out there wear glasses or contacts for one reason or another. Some of the reasons people wear glasses is because their distance vision isn't clear. Driving a car, they can't read road signs, or they can't see things up close, like reading a paper, writing. Those are reasons why people require glasses, and we call these refractive states of the eye. I want to read a little blurb out of a book that I studied for when I became a certified ophthalmic assistant, and it really will just simplify what refractive error means. The term refractive state refers to the relative ability of the refractive components of the eye, the cornea and the lenses, to bring objects into focus on the retina. The two principal refractive states are emmetropia, where parallel light rays are focused perfectly on the retina. So let's talk about emmetropia a little bit. People that have emmetropia, you're perfect. I will say you are perfect. You have the best vision possible without any correction. And when we talk about emmetropia in a normal eye, there are a couple different components that have to come into a line perfectly for this to happen. The cornea, this front part of our eye, has to have a very spherical shape. It can't be long in one direction or steep in another. And you have to have a perfect distance from the front of the eye to the back of the eye. It's usually about 23 millimeters. This just means when light rays enter into the eye through the cornea, usually two parallel light rays, the cornea starts to bend those lights and they meet perfectly together in the back of the eye. This causes your distance to be nice and clear, and you're then able to read like a book up close, things like that. So people that have emmetropia do not need any corrective lenses of any sort. Like I said, whether for distance, whether for near, they don't need glasses, they don't need contacts. Now, the other refractive state of the eye is called ammetropia, is completely the opposite, where light rays are not perfectly focused on the retina to various refractive errors. Now, ammetropia is broken down into 4 refractive errors. And these are used every day in eye exams. Doctors will tell you you have myopia or hyperopia, astigmatism, you're presbyopic. So I'm going to talk a little bit more about those refractive states of the eye. The first one I do want to talk about today is what they call myopia, or being nearsighted. Now, this is the type of refractive error that I have. I can take my glasses off and I got to feel around a room. I can't see several feet in front of me. Unfortunately, I'm blind as a bat. But myopia actually affects 20 to 40% of the population. It's the most popular refractive error, if you want to call it that. It just means that when parallel light rays enter the eye and start to merge because of the bend of the cornea and the lens, it theoretically focuses somewhere in the middle of your eye. So your vision at distance is very blurry. People try to squint to make it clearer. They just can't get that to refocus. So what we do is we prescribe glasses in a minus power. You'll see a prescription written in minus power. But we actually use a minus power, or we create a concave lens in your glasses to bend the light apart, so when they meet your cornea and your lens, they don't start to merge until further back in the eye. And that allows then the light rays to be focused further behind the eye on the fovea, which is the focusing part of our eye. And then it clears up your distance vision very nicely. So like I said, you use what they call a concave cave lens, so it's caved in. So it takes light rays and spreads them out, so when they meet your eye, they don't start to meet till sooner in the back of the eye. Just because the eye is longer, we need to make those light rays a little wider so they're not meeting as soon. The second refractive error I want to talk about is the exact opposite. It's having hyperopia or farsighted. It just means that your eye is a little shorter. Not noticeably shorter. You can't walk up to somebody and be like, oh, you have myopia because your eye is really long, or you have hyperopia because your eye is really short. It just means that when the light rays enter the eye, like up here, and they start to merge, they merge somewhere theoretically behind the eye because the eye is a lot shorter. So what we do is we use a convex lens, kind of looks like an M&M here, or plus power lens, to start to bend those light rays sooner so they meet into the back of the eye perfectly. People that are typically farsighted or have hyperopia have really good distance vision, but near objects are very, very blurry. So these people have a hard time reading. Typically, kids in school, if they're getting headaches and complaining of blurry vision while reading, a lot of times we'll prescribe glasses for reading. It just helps the light rays bend a little sooner so they can focus on the eye, because the lens and the cornea aren't strong enough to bend those light rays. So once we give them a pair of reading glasses, kids pick up in a couple of weeks and they're back to reading normally. They're keeping up in class, things like that. The third refractive error of the eye is astigmatism. It's really, really funny because I have so many people that come in and they're like, I have a disease called astigmatism. It's not a disease. It's just another refractive error of the eye. Astigmatism is related more towards the front of the eye, or the cornea. In a normal cornea with no astigmatism, it's a nice dome shape in all directions. Light rays enter in nicely. They refract and reflect where they need to in the back of the eye. Somebody with astigmatism, they have a dome shape. They don't have a dome-shaped eye. It just means that one section of their eye is more oblong, kind of like a football. We like to see a basketball type shape, but people with astigmatism have a football shape, where in one direction of the eye it's more oblong or pulled out, and another side it's a little flatter. And what happens is when you have astigmatism, when the light rays enter into the eye with astigmatism, they don't merge perfectly. They kind of intersect really funny. They don't pinpoint in the back of the eye. So we use various convex and concave lenses ground on different sections of glasses to theoretically smooth out the shape of the cornea. And once the cornea is theoretically smooth, the light rays will then be able to enter into the eye and merge precisely in the back of the eye. And the fourth refractive state of the eye is called presbyopia. And presbyopia is actually going to affect everybody. And it usually happens about mid-40s. And presbyopia just means that the lens in our eye, which I'll show you the normal eye. When I talk about a lens, I talk about this lens right here. This lens, I always tell people it looks like an M&M. So when we're looking at a distance, it's very flat to reflect the light into the back of the eye precisely. When we go to read, it squishes itself down to add power, or plus power, what we use for reading. And about 40 to 45, that power just isn't there. It can't squish itself down. So it stays very flat. And a lot of times what you'll hear people is saying they need like a bifocal or a pair of reading glasses. And essentially what people are getting when they have a bifocal or pair of reading glasses is magnification. That is essentially what the lens does when it squishes itself down, is it's magnifying the print. So that's when people about 40 to 45 notice that their near vision is terrible. A lot of times they'll be holding things here and then like way out here in their distance vision to read it. So we start putting in bifocals, trifocals, just basically add a magnifying glass to people's power so they can read. And that's typically found on the very bottom of glasses. You'll see like an extra space on the bottom. That's just a magnifier for people. So yeah, that's a brief overview of the 4 refractive states of the eye. Myopia, hyperopia, astigmatism, and presbyopia. It was very, very hard for me to learn at first when I worked, but as you hear about it and apply it to people that you see, it gets a lot easier to talk about and understand. But basically, it's math. It's power and math and length to get the best prescription and pair of glasses that you can get. So people that have myopia or a long eye, we give them minus prescription to stretch that that power out, the light rays. We give people with myopia that minus power so they can clear up their distance vision. People with hyperopia, the smaller eye, we use plus power or a convex lens to shrink the light rays down so they focus on the back of the eye. Presbyopia, it's an add power, and astigmatism, we just grind in different directions to refocus those light rays. Thank you and have a nice day.